This is the Non-AP Calculus Spring Review Worksheet 1. So we're starting off trying to approximate the area under a graph using rectangles. So we're using left-handed rectangles, and if we think about rectangles, the area formula for a rectangle is width times height. We're starting at the x value 4, we're ending at the x value of 23. And we need to identify our the two boundaries that we're working with. And we're also using 3 subintervals. So 3 subintervals, we want to be able to let each subinterval see the same number of order pairs. So we're going to kind of create 3 regions and make sure that each region sees the same number of order pairs. In this case, each region will see 3 order pairs. So the width of the length or the width of each rectangle is dependent on the difference between our x values. So we see that from 4 to 9, this spans a width of 5. So our first rectangle will have a width of 5. Our second rectangle spans from x value 9 to x value 17. So that spans a width of 17 minus 9, which is 8. So we know our second rectangle has a width of 8. And then the third rectangle starts at 17, ends at 23. So that distance is 6. 23 minus 17 is 6. So here indicated are the width of each rectangle. Now make sure that as you find the width of each rectangle that you're subtracting the x values and not the y values. Okay, the difference of the x values will produce the width. And the way that we find height is a little differently. So it says left-handed rectangles. So we have the width component of each rectangle. Now the height is going to be one of these 3 numbers within each subinterval. This would represent the height of a left-handed rectangle. 2 is going to represent the height of a middle rectangle, and 4 is going to be for a right-handed rectangle. If we're just talking about this subinterval here, so within this first subinterval, we see that the left endpoint is at x equals 4, so it's going to take on the height of 1. So 5 times 1 is going to be width and height of the first rectangle. Second rectangle has a width of 8, a height of 4, so that's 8 times 4. Third rectangle has a width of 6 and a height of 7, so 6 times 7 is 42. We add 5 plus 32 plus 42, and we get 79. All right, so in much the same way, when we're dealing with trapezoids, we're also approximating a specific region using geometric shapes. For trapezoids, the formula is width over 2 times height 1 plus height 2. So much the same way, we can just, first off, it's 4 subintervals, so we want each subinterval to span the same number of order pairs, and we want to extend from 2, which is our lower bound, all the way to our upper bound of 30. So it looks like it's going to take up the entire, all the values that we see in front of us. So every interval is going to see 3 sets of order pairs. So then we look at each subinterval. The first subinterval goes from 2 to 7, that's a width of 5. Then from 7 to 16, that's a width of 9. Okay, so on and so forth. 21 to 30 is 9. And then for each subinterval, notice that these are all different subintervals, so we're going to have to rely on 4 separate formulas for trapezoids. So the first trapezoid is width over 2, so 5 over 2 times height 1 plus height 2. Now we're only adding the heights within at the endpoints of each subinterval. So we're going to only add the 6 plus 2. We're not going to use the middle. That's not part of the formula. Okay, and then second region has a width of 9, so that fills in for that portion of the formula there, 9 over 2, and then height 1 plus height 2 for the second interval we have a height of 2 and a height of 5. We add those together. Third subinterval has a width of 5 and a height of 5 and height of 12, so that goes here. And then the fourth interval has a width of 9, and then the two heights are 12 plus 10. We total those four separate areas together, and we get an approximated area of that region being 173 square units. Okay, so number 3, finding the derivative of a function. Notice that this is a little too messy to handle with just one rule. So what we can do is we can rewrite this denominator using parentheses. And once we rewrite it using parentheses, we can bring the parentheses up and make sure, though, that we need to change the sign of the exponent. And we see that within this complex function, we can see this as an outside and inside portion, and that leads us to chain rule. So chain rule says take the outside's derivative, multiply by the inside's derivative. But first, let's identify what the inside and outside portions are for our function. So the outside portion is the 2 parentheses to the negative 9/2. So it's everything parentheses and outside of it. Inside is e to the 3x minus natural log of 2x. So we take turns with each of these derivatives. The derivative for the outside portion, we can just rely on power rule. So power rule will bring the negative 9/2 down. That's here. So bring the negative 9/2 down times 2 parentheses raised to the negative 9/2 minus 1. Right? We always subtract 1 from the exponent if we're doing power rule. So if we do minus 2 over 2. Negative 9/2 minus 2 over 2 gives us negative 11/2. So that completes the derivative of the outside portion. Now we move on to the inside portion, which is the e to the 3x minus natural log of 2x. So e to the 3x's derivative is e to the 3x times 3, right? The rule for e to the u is e to the u times u prime. And natural log of u becomes u prime over u, and so 2x becomes 2 over 2x. So we have our derivative. We fill the parentheses with the original inside portion. And once we fill that in, we basically have our derivative, and the rest of it is just trying to do a little bit of cleanup. So I can push this parentheses, this expression, back down to the denominator to change that to a positive exponent. And I put the negative 9 and the second set of parentheses up top. And the parentheses with the negative exponent gets moved down to the denominator. Okay, so number 4. Find the derivative for our function y is equal to natural log of x square root of 2 minus 3x quantity to the 5th. So the first thing is, whenever I see a natural log problem, I want to look for ways to expand, because this is a messy problem to have to find the derivative. Anytime we can expand for natural log, it'll just make things easier. So this, we can use product property. So product property says we can say natural log of a times b is equal to natural log of a plus natural log of b. So if we can identify this x as our a value and our radical, the 2 minus 3x to the 5/2, this is really to the 5/2. We can rewrite that radical as a parentheses. So then x is our a value, the parentheses is our b value. So natural log of a times b is equal to natural log of a plus natural log of b. Once we have that expanded, we can continue expanding within the second natural log expression, bring the 5/2 down, and now we have an easier time with our derivative because we can just rely on simple natural log rule of u prime over u for each term. So natural log of x, derivative is u prime over u, so 1 over x. For the second term, the 5/2 stays, and then we do u prime over u for natural log of 2 minus 3x. So we get negative 3 over 2 minus 3x. Clean that up, and we have y prime. Okay, so the second video, I will continue with the rest of this review worksheet.